Hello friends, welcome to our channel Smart Techie. Today we shall be dealing with module 4, which basically deals with shear strength of soils. So what is shear strength? Shear strength is nothing but the maximum resistance to the shear stresses which the soil is subjected to just before the failure. So shear stresses develop whenever the soil is subjected to direct compression. Okay, so just imagine that a loaded soil mass tends to deform the soil mass by tearing it into the blocks, causing the movement of one block over the another along the failure plane. Okay, so whenever there is failure in the soil in such a way that one block deforms another block, that time you see that shear failure is basically seen. But that failure is resisted by inherent resistance of the soil mass, which is usually called as the shear strength. Okay, so as I said, it is nothing but the resistance to the shear stresses just before the failure. Okay, so it is basically of the two components: the structural resistance to displacement of the soil because of interlocking of the particles, and the friction between the individual soil particles at their contact points. Okay, so the resistance to the failure is usually obtained either by interlocking of the particles or by friction at the contact points. So we have the Moore-Coulomb theory, which basically deals with the shear strength of soil. Okay, so what we say is the shear strength of soil is basically made out of two components: cohesion, which is denoted by the letter C, and friction angle, which is denoted by the letter phi. It is also dependent upon the normal effective stress, that is sigma dash. Okay, so tau is equals to C plus sigma dash tan of phi. What is this? This is nothing but tau, which is nothing but shear strength of soil, which depends upon cohesion, effective stress, and angle of internal friction. So the shear parameters, that is cohesion and friction angle, are derived from in situ tests and also from the laboratory tests. So if you refer this particular figure, you come to know that this line is nothing but the failure envelope. Equation is nothing but C plus sigma dash tan of phi. And this semicircle which we have drawn touching the failure envelope is usually called as the Moore circle. Okay, you have sigma 1, which is nothing but the major stress, sigma 3, which is nothing but the minor stress. This is nothing but cohesion C, and this is phi, that is angle of internal friction. So the Moore circle of stresses can be drawn using the values of principal stresses. Principal stresses are nothing but, as I said, sigma 1, which is major stress, and sigma 3, which is nothing but the minor stress. Okay, so if data from several tests is available, which is carried out on different samples, we can study the failure, okay, with the help of Moore circles. So you see that there are three Moore circles, that means three samples are usually tested, and then you have a tangential line which is touching all the circles, which is called as the Moore's failure envelope. So here you can basically find that as the number of tests increases, the failure envelope the Moore circle increase, the failure envelope remains the same. Okay, so as per the Moore-Coulomb theory, the failure is essentially by shear, and shear stress at failure depends upon the normal stresses on the failure plane. Okay, and it is a combination between the normal stress and the shear stress. Okay, so the soil fails when the shear stress tau f on the failure plane at failure is a unique function of normal stress acting upon the plane. Okay, so this is nothing but the shear stress at failure, which depends again upon the cohesion, effective stress, and the angle of internal friction. Okay, so then the shear strength, as we already studied, it depends upon cohesion, it depends upon angle of internal friction. The Mohr's theory is concerned with the shear stress at failure plane. Okay, and basically we can draw a plot of normal stress and the shear stress. See here, this is nothing but your normal stress, which is sigma, and this is nothing but your shear stress, which is tau. The failure of the material occurs when the Mohr circle of the stresses touches the failure envelope. So if you draw a Mohr circle and if the Mohr circle is touching the failure envelope, failure usually occurs. So always remember, this is a basic equation to find out the shear stress at failure. Okay, so C and 5 are the measures of shear strength, cohesion and angle of internal friction. Higher the values, higher is the shear strength of soil. And very good is the resistance against shear failure. Now, what are the factors which affect the shear strength of soil? So first one is nothing but cohesion. Cohesion is nothing but attraction between the soil particles, how the particles stick to each other. Internal friction, which is the resistance of the soil particles in sliding over each other. The resistance can be increased by viscosity of pore water and negative pore pressure. It also depends upon structural formation or the resistance offered by mechanically interlocked particles during their dislocation. So coarse grained soils are cohesionless and the shear strength of such soils is mainly due to the property of internal friction. This is quite obvious. If you take clay soils, the stickiness of the clay soil is basically more. So the cohesion is usually more. When you take cohesion less soils, for example sand, they do not stick to each other but they derive their strength from internal friction. So as said over here, fine grained soils are free from internal friction but it depends upon the cohesion. So whenever we take a mixed soil, the shear strength of soil is because of presence of internal friction as well as the cohesion. So in general, shear strength basically depends upon cohesion, it depends upon angle of internal friction. For clay soil, it is cohesion. For sandy soils, it is the angle of internal friction. For mixed soils, it is the combination of both. Thank you.